what's happening. A lot of folks use Ansible for automation of system administration tasks, right? So once an image is installed on a host, there's quite a bit that goes into provisioning the right packages and reducing the chance of making mistakes by capturing that as recipes, or as Ansible calls them, playbooks. What I'd like to talk about specifically is how I test those playbooks to make sure that they're right before they go out to all the nodes in the network. Automation is great for a lot of things, but it can also let you make mistakes really fast in a lot of places. So I think this is a key topic, right? So how do we test that stuff? So Molecule is a Python module. So real quick, let's take a look at the PyPy page for Molecule. There's a description here about Molecule and how it is meant to aid in the development and testing of Ansible roles. I have several roles, interdependent roles, and I want to be sure that they work. As we'll see in a minute, you can do everything from lint to syntax checking and more. So if you want to use Molecule, you can install it with pip. More specifically, inside my repo where I have Ansible roles stored, I keep a markdown file for myself. And these are some directions so I can go back and find things when I need them. And I will probably put a link to this down below. If you want to replicate any part of what I'm doing, I'll make that easy. But essentially, because this is a Python module, I'm going to do everything in a virtual environment so that I don't have too great of an impact on my local machine. So the first thing I do real quick is create this virtual environment, and sure enough, it's there. And then what's my next command? You have to activate the virtual environment, and then you have to install. I'll just type it out. You have to install Molecule, and I think you want the Docker submolecule. So there's different ways you can test this. I guess you'd call it the platform. In this case, we're going to use Docker. You could use, I'm pretty sure you can use AWS and other platforms, but this should go fairly quickly. Okay. So now we're in our virtual environment, and we have Molecule installed. Okay. One quick thing I will say about this, if you look at this directory here, basically I've encapsulated an extra Python install, like a mini Python install, and I don't want that getting checked in to the GitHub repo. It's just unnecessary, right? Dependencies change. This isn't something you need to store. You create this on the fly. So what I'll do is add the directory for the virtual environment into gitignore. And that way I'm not checking in files and making my repo too large with a bunch of extras. So the way you configure molecule is on a per role basis. Like, there has to be a starting point. So I've got molecule set up on a few of these roles, but I'm going to look at the cluster role because I'll show you why in a second. When you first set this up, there's no molecule directory. So there's a command to basically add the molecule directory to the role, and it adds a bunch of templates. It's like one of the first things in the documentation. But let's look real quick at the molecule directory that I've already got. And inside there's a single folder called default, and that is a default scenario. So you can make multiple scenarios per role. For example, I've got cluster node and head node for the cluster, so I could have a role for each. So, but for now, let's keep it simple, right? So here in the default directory, I've got the molecule file that I've modified pretty heavily, a Docker file, which is a Jinja template. This is also a template that comes with molecule, so you don't have to alter the Docker file yourself. So the other files in this directory, converge, prepare, and verify, are part of the test sequence. Some of these come as templates with molecule in order for it to work. Some of them are optional. For example, you could create a destroy.yaml to specify things that you want to happen when you tear the whole test framework down. What I will do myself is put things into, for example, prepare.yaml. So if you look at the sequence, after creation is the preparation. Okay, so prepare for all hosts is going to do a couple tasks here, and these you can see look just like a regular Ansible task. This one is going to install 3 parts of Python 3 via apt and create an etc docker folder. So I'll do this because perhaps the Docker image that molecule is using, let's say it's using Ansible and the playbook really was written for Debian, but there's some reason I need to do that, right? So I might say put things in here to account for that, or install a package like Python 3 that's not in the Docker image that molecule is using as it was specified in molecule.yaml. So if I were to execute molecule test, this test sequence is what would be run. And you can see I have a couple of these things commented out. The other files here, install RST, some documentation that comes with molecule. There's a tests directory, which we'll talk about at the end. Okay, so I think those are the highlights. Well, let's look real quick at playbook. Okay, this is cool because what you can say is, remember I mentioned that molecule works on a per role basis, but here I'm including not just the cluster role, right, the folder for the role that I'm in, but also the py and the common roles. So all 3 of those roles are being tested in this default scenario for molecule under the cluster playbook. I also like to set a variable to that I can use in my plays, so I know that I'm testing. Why might I want to do that? For instance, if there's something that I know, a daemon that I know is not going to start well on Docker, or I'm testing this Pi role, and I know that the Raspberry Pi EEPROM package is not going to be available in the Ubuntu image that I've told Molecule to use, but it is available in the role when it's run on the Raspberry Pi. I would use this in a when clause to skip that task. Okay, so we've seen a couple of these files. Let's try running Molecule and see. I want to show it failing once. So if I say Molecule create in this directory, the issue is you have to be at the top level for the role. So that means, there we go. That means the tasks, variables, handlers, and the Molecule directory are, imagine now, that's sort of our top level. So now if I say Molecule, let's see, I can create, I can prepare. Let's just go for it. What if I say Molecule prepare? I wonder if that's going to work. Already prepared. So that does take quite a while. I think past me had the foresight to prepare some of this. The next step, I'll show it one more time real quick. The next step in the sequence is, after prepare, is converge. So we'll try that one real quick. Just see what happens. So you can see a couple warnings about the requirements file. I think you could create this if you wanted to. When we talk about testing, you'll see there's, like, you can use Tox, you can use PyTest, you can use Ansible test, and those you can all tell where the requirements files are. But I typically won't use that. Like, I'll rely on the Ansible playbooks to install everything I need, and then anything that's sort of special or not in the image like we talked about, I would put in Molecules prepare YAML file. So this does take quite a few minutes. So there, let me see if I can halt this for a second. So here's an example of the variable I mentioned, where I said specifically, hey, we are in the test environment, so don't try to mount any of the NFS file systems. All right, so let's see how this execution went. So it looks like it succeeded our converge. It's, I think, good practice to trying to find my VS Code window. It's good practice to do a destroy at the beginning and at the end of your test run. I didn't do it here because it just takes quite a bit of time. But we do want to, I think we can put in lint too and just see what happens. I think you want to tear those down because you can potentially make a change that if the image is already prepared, created, prepared, and converged, won't show up in the image and won't be tested. That's what I'm trying to say there. So let's try the full test suite as we have it specified in molecule.yaml. So you can see the first thing we got here was a lint, and we got a warning. There's my custom YAML lint RC file, but we got a warning about spaces in our comments. Like, that's not something I typically would allow, but I just recreated this YAML lint RC. I wouldn't allow the linter to annoy me with something like that. Okay, so while this runs, I think we can talk for a second about a piece that folks, I don't think, use very often with Molecule. And maybe they don't need to. Molecule has the ability to, it's got a directory in here for tests. And in fact, it comes with a single default test. So the molecule verify directive is what actually kicks off whatever test cases you create underneath molecule scenario name tests. Okay. I think on its own, like, every time I run Molecule, I'm finding a lot of bugs, and I'm fixing things that I would have missed otherwise. So I'm saying all this to say, I think just as a standalone, if you don't write a bunch of unit test cases and have Molecule run them, there's still, I believe, a great benefit to doing all this. Okay. That said, I think what I'll do, maybe in a future video, is show some Python unit tests against an Ansible install run by Molecule. I think that's interesting, and I think it's a tenet of devsecops, right? It's very good practice to create unit and functional test cases. It increases security, it reduces bugs, reduces your defect density, and so on. So the last thing I want to look at is taking this entire framework we've just created and running it as a GitHub action. The nice thing about GitHub is they will let you but basically use their servers to do your CI stuff on. So GitHub Action is a way that you can start to build your CI/CD pipeline. In fact, there are specific GitHub actions for all sorts of things, not just Molecule. I'll use it to validate my markdown files, or run talks test cases for Python, and so on. Like, there are GitHub actions for so many things. It's really cool. But let's see, we're interested in Molecule. So there are a couple different ones. I think I'm using this one here. Essentially, you would use these examples down here to create something like this. Okay. So this is the specifier for the action that's going to run when I do a pull request to GitHub. They make this pretty easy to use. You take a file, this YAML, and you just check it into the repo under .github/workflows, So here it is again, that same file. And this, you can specify different times to run it here. So push, pull request, both. When you merge to main, whenever you feel like you need to do that testing. So let's see if, let's do this. If I were to, let's see, so we have a small change here, so I'll say, so if I say git checkout, we'll call it dev37. Okay, so we're gonna say, let's make sure that that change is not gonna break anything. Okay, so it looks like I just changed the test sequence a little bit, but I think this will work. So if I just say git add molecule, and git, oops, let me put a little quotes around that. Okay. That's a git commit. Oh, it's got my pop-up for my passphrase. My dog has fleas. Okay. Origin dev 37. Right? Right. Okay. So what it's telling us is go back to the repo. And sure enough, recent change. So let's do the PR. So let's just look at the change real quick. It looks like we turned on the linter. I don't know if that's going to work. I don't know if the module would get installed for that. But we'll try it anyway, just to illustrate the concept. Okay. So if I create the pull request, it says, let's see, show some checks. There we go. So let's see if I click on details of this action. We can watch it run for a second. But it's easy, right? It's very easy to implement one of these actions that folks have written and create that YAML to get them to run in your repo. The nice thing about this is if you're on a project with more than just yourself, you can use this to enforce the policy, right? Like every time the team does a check-in, I want it to be linted and prepared, created, converged, tested, whatever is needed. So it's pretty powerful stuff and pretty interesting stuff, I think. It takes a little bit of work to get it the way you want, but it's worth doing because, like I said, it finds a ton of just minor mistakes, things you thought you changed and didn't, and so on. So just for fun, take a last look here. Looks like everything completed successfully. Nice big green check mark. In fact, we got a nice green check mark here, and our action passed. So success. Woo. Yeah, so pretty cool stuff. Hope you find it useful, and cool.